Hello, welcome for this session. In the previous session we looked at the characteristics or the physical proper and chemical properties of metals. Here we will be looking at some elements that are non-metals or either metalloids. So when we are looking at metalloids, for example, they are in between non-metals and metals. So we will base ourselves first to look at what are non-metals. So many non-metals are gases. Many non-metals are gases at room temperature. Many non-metals are gases at room temperature. And they include oxygen, nitrogen, fluorine. So if we are giving examples here, they include nitrogen, oxygen, fluorine, chlorine, which is one non-metal, and there is one non-metal, bromine, which is a liquid. So bromine is a non-metal that is a liquid. So we can say that a majority of them are gases at room temperature, but bromine here is unique in that bromine is one non-metal that normally exists as a liquid. The solid nonmetals may include, some of them are solids, so solids, nonmetals. Solid nonmetals include carbon, phosphorus, selenium, sulfur, and iodine. I think when we see here, for example, in our picture here, we are having pictures here. We have iodine, we have phosphorus, we have sulfur, we have carbon. These are all solid. These are all solid. One of the characteristics of non-metals is that it has a low conductivity. It has low conductivity, which means it does not conduct electricity. So we can say it has low non-metals have low conductivity, which means basically they don't conduct electricity. A nonmetal is an element that is a poor conductor of heat and electricity. A nonmetal is an element that is a poor conductor. It's a poor conductor of heat and electricity. So unlike metals, which are good conductors of heat and electricity, Non-metals are poor conductors, and this means they basically don't conduct electricity. So there are a few non-metals than metals. There are a few non-metals than metals. There are a few non-metals than metals. So we can say that normally we have around three-quarter of elements are metals. So the remaining 1/4 will make the metalloids and the non-metals. So let's go and look at specific type of non-metals. So phosphorus is one of the 5 solid nonmetals. Phosphorus. So we will look at phosphorus. When we are looking at phosphorus as one of the 5 solid nonmetals, phosphorus, pure phosphorus, is known to exist in 2 common forms. So pure phosphorus exists in 2 forms. Is known in 2 common forms. One of the forms is red phosphorus. One is red phosphorus. Which is dark red powder. Normally exists in dark red powder that melts at 597 degrees Celsius. On the second one is white phosphorus. Which is a waxy solid. This is a waxy solid that melts at 440 degrees Celsius. 440 degrees Celsius. So because it ignites in air at room temperature, because it ignites at room temperature, it is normally stored underwater. It is stored underwater. So the white phosphorus is stored underwater because of it being very reactive. So phosphorus is too reactive to exist in pure form in nature. In fact, its presence occurs in rocks. So it occurs in rocks. Where it combines with oxygen and calcium. Where it combines with oxygen and calcium where it combines with oxygen and calcium. All living things contain phosphorus. All living things contain phosphorus. All living thing contains phosphorus. So the elements in group 18 of the periodic table are noble gases. The elements in group 18 in group 18 of the periodic table are known as noble gases. So these ones are called the noble gases because they are stable and less reactive. So they are generally unreactive, although some can be made to form compounds, so they are generally unreactive. They are generally unreactive. But I said that some of them can form compounds such as xenon. Some can form compounds such as xenon, hexafluoro, platinate, hexafluoroplatinate. So low reactivity makes the noble gases very different from the other families of elements. Group 18 elements are gases at room temperature, and they include neon, argon, krypton, and xenon, which are used to make light signs. So here they include neon, which is used to make neon lights, argon, krypton, and xenon. All these are used to make light signs. Light signs. And the reason why they are used to make light signs is basically because they are unreactive. So as you look from the from the left to the right on the periodic table, you can see that the metalloids are found between the metals and the non-metals. So what are these metalloids? So a metalloid is an element that has some characteristics of metal. A metalloid is an element that has some characteristics It has some characteristics of metals and non-metals. Some characteristics of metals and non-metals. So because it has characteristics of metals and non-metals, all metalloids are solids at room temperature. All metalloids are solids at room temperature. All metalloids are solids at room temperature. They are normally at room temperature, they are normally solids. They tend to be less malleable than metals, but not as brittle as non-metals. They tend to be less malleable, which means it is difficult for us to hammer them into sheets than metals. It's easy to hammer metals into sheets, but it's difficult for you to do it with the metalloids, but not as brittle as non-metals, but not as brittle as non-metals. So this means that for them, they are not easily breakable, just like the non-metals. So some metalloids, such as antimony, have somewhat metallic luster. Some have metallic luster, like antimony. So metalloids tend to be semiconductors of electricity. Metalloids, so I said here, some metalloids such as antimony have somewhat metallic luster, which means they are shiny. Metalloids tend to be semiconductors. Metalloids tend to be semiconductors. Tend to be semiconductors. Of electricity. Semiconductors of electricity, that is, their ability to conduct electricity is intermediate, i.e., their ability to conduct electricity is intermediate. So they are not good conductors, but they are also not poor conductors. They are intermediate between metals and non-metals. Metalloids are used also in the solid state. They can be used in the solid state circuitry. They can be used in the solid state circuitry. They can be used in the solid state circuitry. Found in desktops, found in desktop computers, digital watches, televisions, and radios. Televisions and radios. So you can see, even though they don't have the properties of metal, they are also as very important, and because of their properties, they are uniquely used for specific purposes. So we will stop here, and in the next video we will be looking at the scientific method.